Let us see what is Coulomb's law. Colonel Charles Coulomb, he was a French army engineer. He has conducted some experiments and he found that if there are two small tiny objects, we call it as point charges, which is now separated by a distance. Let us call the distance is r, and let the charges be q1 and q2. He said that through his experiments he found that the force is proportional. The electric force between these two charges is proportional to the product of each charges, that is this q1 into q2, and is inversely proportional to the square of the distance. That means the force is equal to, earlier I said it is proportional to, I am putting it in equal sign here, equal to, we put a proportionality constant, q1 q2 by r square. In SI unit system, this charge q is measured in coulombs. Q is measured in coulombs, that's a unit of the charge, and the distance r is measured in meters, and the force, the final force which we are getting, is measured in newtons, and the proportionality constant k is now defined as 1 by 4 pi epsilon. In free space this will become epsilon 0, epsilon naught. Okay, and this epsilon naught is nothing but the permittivity of free space. This is the permittivity of free space, which is evaluated as is equal to 8.854 into 10 power minus 12 farads per meter. That's a unit of epsilon. Now we can write the final equation of the force, that is F is equal to Q1 Q2 divided by 4 pi epsilon r square. This is the final equation of the force. This is basically the magnitude part. So force is a vector quantity. We have not seen its direction yet. This is just talking about the magnitude of the force, that is F equals Q1 Q2 divided by 4 pi epsilon r square. Let's see what is Coulomb's law in vector form. Here when we talk about Coulomb's law in vector form, we basically say that the direction, we are including the direction also in our derivation. So we already seen that the magnitude part of this Coulomb's law, that is F is equal to Q1 Q2 divided by 4 pi, the distance r, the distance square, and we don't have the direction here. So in order to know the directions, basically we need to keep the point charges in space, and let me say this is q1 and this is q2. Let the distance be a I will call now this as a distance vector, okay, which is starting from q1 to q2. So let me call this as a vector r. Now you know that this vector has a direction. Let me assume the force is experienced by q2. The force is experienced by q2. Sorry, where is it? Yeah. The force experienced by q2, force on q2 due to q1. So basically we are trying to find out F2, force on q2 due to q1. So let me say this is F2. We will always say that the force is in the direction what I am showing in this arrow here. Okay? That means it's the same direction as that of r. Now in this case, vector r, to know this vector r, we should be knowing what is the position of q1. I will call it as x1, y1, z1, and the position of q2 is x2, y2 and z2. Since we are including the direction also in this force equation, now the force become a vector. So that's why it is vector force. You can write this equation as this equal to, I'll just rewrite the magnitude part here, q1 q2 divided by 4 pi epsilon. Up to this is the same thing. And when it comes to r, the distance, if you see, now the distance is nothing but the magnitude of this vector r12. Okay, the square of that, yeah, so r square. And the direction of this vector, if you look at this part, let me show you this direction. If you see, it is in the same direction of r12. You know that in any vector notations, the direction is represented using unit vector. So the unit vector in the direction, unit vector in the direction of r12. We will call it as, maybe let me call it as A12. A12. So this I can rewrite this as A12. A12. This is the direction. Okay. Now in this equation, we should be knowing what is R12 and what is A12. Then this equation is complete. What is R12? R12 is the vector starting from Q1 ending at Q2. So R12 can be written as the x values, x2 minus x1. It is from starting from 1 and ending at 2. So x2 minus x1 in x direction plus y2 minus y1 in y direction, z2 minus z1 in the z direction. This is the vector r. And what is the unit vector in the same direction? It is nothing but the vector itself, the vector itself divided by the magnitude of the vector. What is the magnitude of the vector? It is, the square root of the component part square, that is x2 minus x1 square, y2 minus y1 square, z2 minus z1 square. So this is the magnitude.